Good afternoon, students. Can you hear me? Can you see the screen?
Yes, sir.
Yes, sir.
All right, good. So I'm gonna just run through the questions that I gave you to do on this paper. We're basically doing some revision work. So looking at the topics, questions on the past papers and the topics that we have covered so far in the program. So we're gonna be doing some questions in this pure maths paper, and we're gonna do some questions on the odd maths paper. And there are questions on the pure maths paper that the odd maths students are to do as well. So what should I do it in? I should maybe do the odd maths paper first, because then I'll be covering questions that the odd maths students don't need to do. So what I'll do, I'll cover the questions that are odd maths and pure maths, and then I'll come back and do the questions that are straight pure maths. All right, so that's what I'll do. So let me do that. So I'm gonna cover the odd maths questions on this paper first. I'm going to cover the question. Let me do the odd maths paper first. And then there are odd maths questions on this paper as well. I'll clear those first. All right, so I'm going to do it that way. Let's clear the odd maths questions first. Yep, I think that's the right way to do it. Now, so this is 2016 exam paper. This is odd maths 1. And I did give you number 1. I don't know, based on the topics that we have done. So we don't know the functions yet. So function no longer odd maths. So this is the first question I gave it to do on this paper. All right, now this is what we call a disguised quadratic equation. All right, on the indices topic, logs and indices. So we really want to, this can become a quadratic in 2 to the x. It can become a quadratic in 2 to the x. So really what I want to do is break this one up. So we have to recognize this as 2 to the x times 2 to the 1. That's what that is. Alright, so we're going to write it as 2 times 2 to the x. That's what this becomes. 2 times 2 to the x plus 5 times 2 to the x minus this 3 equals 0. That's like a quadratic equation. The same, basically a quadratic equation similar to 2y over I need a square. Need a square on this. Oh, that's 2 to the x squared, right? Because why is this 2 to the x squared? Let me show you. This term is same as 2 to the 2x times 2 to the 1. Then this 2 to the 2x is the same as 2 to the x squared times this 2 to the 1. And then all I do is put this 2 in front here. So that's how we get this term. I think I wrote something wrong the first time, but this is it. This is the correct thing now. So this is like 2y squared plus 5y minus 3 equals 0. Alright, and we'll factorize and solve this for y, but we don't have to actually change it to a y. We can just work with the 2 to the 2x as the variable, alright, in this quadratic equation. So it's become, if we factorize this, it will be 2 times 2 to the x times 2 to the x, and then this factor of 3 is 1 and 3. We have to put it so that the far product and near product gives you a difference of 5. So we need to put the 2 with the 3 over here and the 1 here. Signs in bracket are different. The larger product a plus. So the larger product is the far product, meaning that one positive, this one negative. That's equal to 3. Alright, so those are the two factors right there. And then we say, okay, equal to not 3, equal to 0. Oh Lord. Too many mistakes, Mr. Shaw. Alright. So if this one equal to 0, then we will have 2 to the x. That's this 2 to the x. Carry over the 1, it become a positive 1 over 2. And if this one equal to 0, then it would be 2 to the x equal negative 3. Now this one is not valid, doesn't have any solution. This one is not valid. Why is it not valid? Because a positive number raised to a power can never be negative, regardless of what the power is. A positive number raised to a power that is real cannot be negative. And if you were to solve it anyway by trying to get the x out of the power by taking the log of both sides, then you'll be taking the log of -3, and the log of a negative number does not exist in real life mathematics. So really no solving this. For this one, this can be written as 2 to the -1. So this reduces to 2 to the x minus equals 2 to the -1. And so the x equals -1. X equals -1. That's the solution right there. But okay with that?
Yes, sir.
Yes, sir.
Yeah.
All right. Let's see what other question. Then I gave you this one to do as well. This one wants us to make C the subject. This C up here, want to make it the subject. And to get this C from out of the power, basically you would take logs, all right, to get the whatever. If you have a quantity or a variable in a power, you want to get it out, you take logs, all right. What we can do, we can move this key first by dividing it under here. So we have this index to work on. So we're gonna put T over K equals P to the H over C. H over C, Mr. Shaw. Alright. Then now to get this out of the power, we're gonna take logs. But really the C alone need to get out of the power, you know. And this is really 1 over C. Alright? It's really 1 over C. So it's like 1 over C times H. I want to get the 1 over C out of the power. So I'm going to take logs of both sides. This is odd math, so can I take log of T over K equals the log of P to the H over C. Or if you like, we can write it as 1 over C times H. And we do have to move both of them out of the power. We can choose to move this alone out of the power. And so we would get the log of T over K equals 1 over C times the log of P to the H. Alright. And I want to make this a subject, so we can basically take it and multiply it up here and then take this and divide it under. Alright, so over here, I'm counting over here. We're going to get, multiply up the C, as I said, we're going to get C equals, it's going to be this log expression, which is the log of P to the H over the log of this expression when you divide it under. The log of T over K. And that means C the subject. But this is not the only way that this expression can turn out. Alright, this can turn out a made of way. We could have had a case where we have the H in front. We could have a case where this is broken up into the log of T minus the log of K under here. All sort of things. Right? So there are multiple ways this could have worked out. But I'm leaving this as my answer right now. But okay with that?
Yes, sir.
Alright. Then we have this simple logs equation to solve. Once we do, we'll see the base on it, and we'll see log 1 is log to base 10. So solving this and that, this equals that. So since we have logs on both sides, remember when solving a logs equation and reducing a log expression, you want to reduce this down to one of two things. Either going to reduce it to an expression looking at the log of a number to a base equals a power. Then this would imply that this number n would be equal to this base raised to this power. This base is b raised to the p, and then you solve this, right? Would solve this. Or you can reduce this to log of a number on one side equals log of another number on the next side, and both of them have the same base. Then this would now imply that the n equals m. n equals m, and then you would solve this. So that's the aim in solving most logs equations, right? Equations in log. So because we have logs on both sides of this, we can basically work towards using this one. All right. So when you add logs, you add two logs, it becomes the log of the product. So this side becomes, let's go for the blue. This side becomes the log of x plus 1 times x minus 1. Equals, and then over here now we can take this 2 and bring it up here as a power. So it becomes the log of x plus 2 squared. That's it. If we have, this is now like our m, n, and this is now like our m. And so we're using this one, so they are equal. Right? So it means then that this expression equals this expression. But this expression is the difference of two squares, right? It is x squared minus 1 equals, and this expression now, if you expand it out, it becomes x squared plus 4x plus 4. That's what this thing becomes if you expand it out. So we're dropping the logs. Alright? Now these two negatives will cancel each other. The squared, I mean, we cancel each other. Those two terms, let's underline them. Cancel each other. I'll solve now for this x. Alright, so we take this 4, bring it over here, put it with the negative 1 and get negative 5. So we get negative 5 will be equal to this 4x right here. And to make x a subject, we will now divide by 4. So what that means is that the x is equal to minus 5 over 4. Alright, that's the only solution I'm seeing there. And is this a valid solution? Yes. No. Technically, it's not a valid solution, you know, because if you put x equal negative, put x equal negative 5 over 4 here. No, not there. Here. You'll be finding the log of a negative number. Alright? You'll be finding the log of a negative number. And you can't find the log of a negative number. So this answer is not a valid answer. So this has no real solution in a sense. So this answer is not valid. But I still think it's not a valid value for the given equation. Not valid. But I still think this is the answer they're looking for. You get me? That's the answer they're looking for. Just that it could not work right here. Because if you put x there, you will calculate the log of a negative number. Alright, so that is it. But let me just double check if we did everything right. So we multiply these two things, log of the product. Bring this up here and make it a square. And then we expand this, it becomes the difference of 2 squared, x squared minus 1. Expand this side, we get x squared plus 4x plus 4. The x squares cancel. Then this 4 comes over here with this negative 1 to become negative 5. And we divide by this 4, negative 5 over 4. That is it. That is it. Are you alright with that?
Yes, sir. Sir, can go back to the first part. I just want to see the answer I got again.
Up here? Around the industries. Alright. This one?
Yes, sir.
But as I said, it doesn't have to be this, you know. Another expression I can see right off the bat, put right down in purple, is that this h could have come to the front. So it could have been c equals h times the log of p divided by, and this under here, if we were to break it out using the laws of logs, it would be the log of t minus the log of k. So this is another expression that c could be. C could be this as well. I put an R on this. R could be that. Okay?
Okay, sir.
Alright, good. So let's move on to this part. This one said determine the nature of the roots of this equation. Remember, the nature of the roots is determined by the discriminant. So you just need to calculate the discriminant of it. There's no 1 mark for it. So calculate b squared minus 4ac. Simple as that. And b squared minus 4ac, if you work it out, the b is 3. So it's 3 squared minus 4 times a, the a is 2, times c, the c is negative 9. I don't if I have to work out the value now. This minus minus makes this a plus. So it's going to be greater than 0. It's going to be greater than 0. And when the discriminant is greater than 0, then roots are real and different. So I'm going to write roots are real and different or distinct. Distinct means that they are different. So that is it for your 1 mark. Then down here now, so it has 2 real roots. In other words, it intersects x-axis at 2 points. That's what they're basically saying. That's what happens, right? Alright, so this one now, the function intersects x-axis. This function now, as is related to this equation, we cut the x-axis at 2 points, 2 different points, because we have 2 real distinct roots. This one says now, this expression, and we have to sketch a graph and show the minimum value. So to show the minimum value, we need to calculate the minimum value. So one way to get the minimum value out of this is to complete the square, right? And get it in the form, a into x plus h squared plus k. Get it in that form, and then the minimum value will be this value. And the value of x rate is minimum will be minus h. So the minimum point will be minus hk. Alright, if you're using that method. So we're going to compute the square of this so we can see the k. Or there's a way to calculate the k too, you know. A way to calculate the minimum value. Oh, they want us to sketch the graph, and we're going to show the minimum point. So we need both values, the h and the k. So a way to do it is to get it in this form so we can see what it is. So we're going to compute the square. Let's do it. So computing the square, the f of x is going to be, at CSEC we taught it using a formula method. We're going to do a process method now. So you factorize these 2 terms first. So you're going to get 2 into x squared plus, factor 2 out of that, we're going to get 3 over 2 x, and then subtract this 9 again. You complete the square of these terms now. So it becomes 2 into x, and then half of this, which is my plus 3 over 4 squared minus the square of this, which is 9 over 16. That's it. We have completed the square of these 2 terms, and you subtract back this 9. So what did we do? What did we do? We did half of this, and then we subtract the square of that. That's the process in a nutshell, right? I just need to expand this out back now. Alright. There's so much space to give us to sketch it. Okay. I must give us some space to work. Alright, and then now we're gonna get, if we're gonna expand this now, we're gonna get 2 times x plus 3 over 4 squared. Then 2 times this becomes minus 9 over 8 minus this 9 now. So 9 multiplied by 8 over 8. So we can have the same diameter. This is 72 over 8. So it becomes 72 over 8. And then 72 and 9, because both of them negative, is 81. So it's negative 81. So it becomes 2 into x plus 3 over 4 squared minus 81 over 8. So this is a minimum value with the negative, and it's minimum when this x is negative that. Alright. So R becomes the f of x becomes equal to this when this bracketed term is 0. So it's when x equal negative that. So we can write it out here. Minimum point just like I set up here is minus this value. Because this is a plus and we have a plus here as well. So it's minus that value. So it's minus 3 over 4 and the y value is the k value. Negative 81 over 8. Alright. Also this c value is y-axis intercept. So the y-intercept is 0c, which is 0, negative 9. That's where it crosses the y-axis. 0, negative 9. Right, all these things we need to just know. Right, and the graph has a smile shape because the a is positive and to the minimum point. That's sketch for one, so let's sketch it over here now. So let's put on our wire, and it asks us to show the roots, just the minimum value. Alright, so doing a sketch now. Alright, so let's sketch it out in red. The first one is going to have a smile shape, right? But it can turn up here, can turn up here, down here, down anywhere, can turn anywhere. No, it turns right here. Now where would that point be? That point will be where the x value is negative and the y value is negative. Means that it turns somewhere down here. Then where does it cross the y-axis? It crosses y-axis at 0, negative 9. 0, negative 9 is somewhere on the negative part of the y-axis. So we need a smile graph that turns down here and crosses the x-axis down here. And it's a sketch that we're doing. So I'm just going to sketch it and move this y-axis and put a little bit more over to the right. This y-axis, slide it over a little bit. Like so. Good. So turn down here, cross down here. That's what we're drawing. So we'll just go something like this. It's not to scale, guys. Something like that. That's a good enough sketch. So right here, the y-axis intercept is 0, negative 9. Right here, the minimum point is this minimum point, negative 2 over 4 and negative 81 over 8. And that's your sketch as requested. That's the sketch. Very good. They did not ask us for the roots, guys. They did not ask us for the roots, so we're not putting it. Alright, if I finish this exam paper and do all the questions and still have time, I will maybe come back and work out these two roots from this equation up here. What are the exact values? Let me see. Yes, this guy like you can factorize now. Let's see if we can factorize it. So factorize this. Looks like 2x and x. Factors of it 3. Factor over 9 is 3 and negative 3. 3 and negative 3. And we put the plus. Doesn't matter. So this will be 6x. This will be minus 3x equals this 3x. Yeah, so those are the factors, So this one actually easy, so I can put them in. Quite easy. So those are the two factors. So those are the two factors. The roots are from this one, 3 over 2, and from this one, negative 3. These are your roots. Right here is 3 over 2, and right here is negative 3. You realize you can get them so easily. So that is just I didn't specifically ask for them, but since it's so easy to find, might as well. Very good. But alright.
Yes. Yes, sir.
Alright, beautiful. Let's continue. On here now, it says evaluate this sum. Alright. So I want to say it's more than likely is a GP. Well, let's write this first as 1 over 3 to the n. So this is the same as the sum of 1 to 25 of 1 over 3 to the n. So we're working with the negative power to do that. Then what we need to do is write out a few other terms and see what we have. The first one will be 3 to the 1. So it'll be 1 over 3 to the 1, which is a third. As a summation, so the next term is plus 1 over 3 squared. And then 1 over 3 cubed. And it will go all the way up until we reach the last term of 1 over 3 to the 25. So there are 25 values there from n equals 1 to n equals 25. But this is a GP. What is a GP? You keep multiplying by 1 over 3 to go from term to term. So it's a sum of a GP. So what we have is a GP with the A equals 1 over 3 and the R equals 1 over 3. And the number of terms in this GP is 25. I want to find the sum of them. So the sum of that GP, remember sum is A into 1 minus R to the n over 1 minus R. So it becomes A, which is a third up here, so into 1 minus, the R is a third as well, so it becomes a third to the 25 over 1 minus a third again, the R is a third. That's what we're solving. That is what we are solving. You can put this in the calculator and work it out, because in this exam you can use a calculator. So square should be 25 here. The power is 25. 4 here is 25. Alright, so we're using the summation, the sum formula for GP. Well, the sum of a GP is A into 1 minus R to the n over 1 minus R. So we're using. Alright, I think this is going to work down. This is going to be a something infinity. See, this is a fraction. Look, this is a fraction, you know. The R is a fraction. 25 is large, you know. So it's going to work out to be basically almost 0. This is going to work out to be 0. So it's actually going to work down to a third over 1 minus a third. Multiply it up here by 3, multiply only by 3. It's going to be 1 over, this becomes 1. This becomes 3 minus 1, which is 2. So when 1 is going to become a half. It's going to work down to be a half. Let's put in the calculator and see if we get it. This looks like it's going to be a half.
Yes, sir, it's a half.
Half? Oh, beautiful. Yeah. Beautiful, beautiful. So it really was a something infinite. This is a fraction, and 25 is large in terms of a number of terms. So this work out basically to be 0. So it's really something infinite, this source. Alright, that's it. Next question down here. It says a man invests X dollars in a company in January 2010. Alright. On which he earns quarterly dividends. So quarterly, remember there are 4 quarters in a year, right? So in January 2010 is when he started. Alright, he said at the end of the second, third, and fourth quarter in 2011. So we're going over 2011. So if you reach over 2011 and you reach the second quarter in 2011, that is the 6th term. Okay, you finish 4 quarters in 2010, you know, and you reach the second quarters in 2011. So you're talking about the 6th, the 7th, and the 8th terms you reach. These are the values. Alright, so the 6th, 7th, and 8th are those values. So 6th, 7th, and 8th are 100, 115, and 130. Now clearly that's an AP. Right? 3 consecutive values and they differ by 15. So plus an AP with a common difference of 15. Alright, I don't know what the first term is yet. But anyway, respective is a calculate the total dividend on his investment at the end of 2016. So we need to know how many quarters there are up to 2016. And we're doing the sum to that number of terms, right? So we're talking about we have to include the 2010. So it's with the 7 years, 7 years. 2010 to 2016 is with the 7 years because you have to include the 2010. See it here, 2010, 2011, 2012, 2013, 2013, 2014, 2010, 11, 12, 13, 14, 15, and 2016. Right, 1, 2, 3, 4, 5, 6, 7. And there are 4 quarters in each. Each year has 4 quarters, right? So the number of quarters, which is the number of terms, number of terms, a number of payments, number of dividends, right? This is called a term. Each term is a dividend. Becomes 7 times 4, it's 28. So we want the sum to 28 terms. Right, that's what we want the sum to 28. But we need to find the A. We know the D already, we need to find the A, right? So let's find out what the A is. So the 6th term is 100, and the 6th term is A plus 5D is 100, and the 7th term is 115. So A plus 6D is 115. So from this we're supposed to be able to, well, the D is 15 clearly. Oh, we couldn't know it from here, so we can use one of the values. The D is 15. From here to here to here, the D is 15. So we can write that the D equals 15. And the 6th term is 100. So the 6th term is A plus 5D is $100. So the A is 100 minus 5 times the D, and the D is 15. So we need to calculate now. So what is that A, guys? 5 times 15 is how much? 75? 75 from 100 is 25. So the A equals 25. And then we need to find the sum to 28 terms, where 25 terms, the number of terms is 28, sorry. The first term is $25, right? $25. So the sum, remember, is n over 2 into 2a plus n minus 1d. So the n, as we said, is 28 quarters over 2 into 2a. 2 times a is 25 plus n minus 1 becomes 27 times d is 15. That's what we're working out for the sum. That's what we're working out, and we will have the sum of the dividends. See, I say calculate the total dividends, which is the sum. Would it be right? So it's a fraction. 20 over 2 is 14. Could I write 14 times bracket, and this 2 times 25, right? It says 50 plus n minus 1 is 27 times 15, the d. 27 times 15 close bracket. So we get 630, 6370. Put dollar sign in front of it. 6370. That's the total. But after that, Very good. So this is just them trying to bring a real life situation to our AP GP, right? And this was an AP, but they like to do that, try to bring real life situation to it so they can apply AP GP to a real life situation. And they try to do that with the questions most of the time, every year. That's what they try to do. Are they okay? Can we move on?
Yes, sir.
All right. Issue number 3. I gave you this question as well. I gave you this question. It says, M and N are the endpoints of the diameter of a circle C. Determine the equation. Remember, the equation of a circle is in this form. X minus A squared plus Y minus B squared equals the radius squared, where the A and the B is a center point, coordinate of a center, and R is the radius. Now, how can we find that center point? So it's a circle. They give it
Yes, sir. Um, I'm not sure if what I did was correct. What I end up doing is that I find the midpoint to get the center point, and then for the radius, I find the length and then divide it by 2.
Yeah, that would work. Or you could find the distance from the center to any one of these. But the midpoint is the center for real, because these are endpoints of a diameter. Right, so negative 1, 4. So like you have a diameter like this. Up here so it's M. Down here so it's N. This right here is O. So I'm saying you could find this point and then find the distance between here and here. That would be a radius. Right? That is it. Yeah, that will give you the right answer. So let's see. So circle is C. Let's call the midpoint O. So O would be the average of the two x values for the midpoint. That's 3 minus 1 over 2. Average of the two y values, which is 2 plus 4 over 2. So the center point will be, this will be 2 over 2, which is 1. And this will be 6 over 2, which is 3. That's the center point. And then the radius now is from this center point to any one of them. What about this distance between this and this? So the radius would be, for example, OM. Distance between O and M, which would then be the square root of difference in the 2x value squared, which would be 3 minus 1 squared, plus the difference in the 2y value squared, which would be 3 minus 2 squared. Now this under here will be a 2 square, which is 4. This under will be a 1 square, which is 1. 4 and 1 is 5. So we're getting the square root of 5. That will be the radius. Alright? So the radius squared is going to be 5. So the equation that they want would be x minus 1, that's the center point, squared, plus y minus that value, squared equals, r is equal to this, you know, so r squared is 5. And that's the answer right there. That's what they got? That's what they got? Student who said they did it.
Yes, yes, sir.
Alright, good. Alright, let's continue. This one says now we have to find the equation of a tangent at this point. Right? And that's a typical question that asks in AdMaths. There's no need for us to getting questions like this wrong. Alright, so you have the circle. And we have the center point, which is what, 1, 3. Yes, 1, 3. And they want the tangent at the point negative 1, 6. So that they want this red tangent here at the point negative 1, 6. That's the point P. And as always, the normal is your best friend. This normal is your best friend because it is perpendicular to the tangent. And by finding going to the normal, then put t for tangent, and n for normal. This purple line is a normal. So the gradient of the normal can be found because you have these 2 points that it passes through. So a difference in y by difference in x. So it will be this y value minus this y value. It will be 3 minus 6 over this x value minus this x value. That would be 1 minus a negative 1. So it will be negative 3 up here over this work out to be 2. Because minus minus a plus over 2. That's going to be normal. Now the tangent is perpendicular to it, so the gradient of a tangent is minus 1 over the gradient of a normal. And this calculation can be done by flipping the gradient of a normal and changing the sign. So if we flip this and change the sign, it becomes 2/3. So that is the gradient of a tangent. So I'm going to use this gradient and this point now to get the equation. Alright? So nice and easy. So you don't worry about that space, guys. So the equation of that tangent is y minus the y value at the point equals the gradient of a tangent into x minus the x value at the point. So it's y minus the y value at the point is 6. Point of tangent is 6. Then the gradient is 2/3 of a tangent. X minus x value right here is negative 1. This minus minus becomes a plus. Let's put a plus on there in blue. Alright, and then to simplify this quickly, we can take this 3, multiply across it by those 2 values, and get 3y minus 18 equal. Take this 2 and multiply it inside this bracket. So get 2 times x is 2x, and 2 times this positive 1 is plus 2. And if we transpose this over here, we get 20. And we can make this a little smaller. So we can just put on the last line. Let's make it like a smaller like that. Shift it down a bit. So this becomes 3y equals 2x plus 20. That's my answer there. Are you good at that? Any questions?
No, sir.
Alright, good. Good. So I was skipping this one. I'm skipping that one. Don't do this yet. I want to do this in January. I think we're done on this paper. Alright, we're done on this paper. Yep. Yeah, done on this paper. These are the topics we'll be doing in the new year. Alright, that was the 2016 odd months.
Sir,
Yes? Is there another question I was supposed to do? Speak now?
I don't think so, sir.
I don't think there's another paper. I know the topic on that paper that we have done it in class. So now on this pure maths paper. So I'm going to do the odd maths ones on the paper first. And then I'll do the pure maths ones on the paper. Right? The ones that are same as odd maths level. So look at what those questions were. Always the first question, the first part of the first question. So let me see. Alright, so 1A, 2A, and 4D. And each of them is a different question. So this one, 1A. So advanced students can get a question just like this on their exam paper. Alright, even though it's on a pure maths paper, yes, you can. This question gives us this function. There's 2 unknowns in it, so we need 2 equations to solve for them. It says, given that x plus 3 is a factor, and there's a remainder of 10 when it is divided by x plus 1, show that P is this, and that is, I like this question, we'll get the answer, you know you're right. All right, so let's go. So x plus 1, x plus 3 is a factor, which means that f of negative 3 is equal to 0. All right, f of negative 3 is equal to 0. If f of negative 3 is equal to 0, it means I want to plug negative 3 in here and in here and in here, and then equate that to 0. So negative 3 right here become negative 3 cubed, which is negative 27. And negative 27 times 2 is negative 54. So I get negative 54. Then negative 3 right here is going to become a 9, a positive 9. So we just get minus 9 right there. And then negative 3 right here is going to make this become minus 3p. And then this q is just by itself, it's as a constant. That's all equal to 0 because the f of negative 3 is 0. So this is f of negative 3 equal to 0. So this one become negative what? 63. So negative 63 minus 3p plus q equals 0. Alright, that is that. Then the next thing they told us, let's go for it in blue, that it leaves a remainder of 10 when divided by x plus 1. So x plus 1 gives a remainder which is equal to 10. What does that mean? It means that f of minus 1 is equal to the remainder of 10. So I plug minus 1 in there, it works out to 10. That's what basically they're saying. Let's see what that part in purple. So minus 1 in here, you're going to make this become a negative 2. Minus 1 in here, we're going to turn this into a 1, so we're going to get negative 1. Minus 1 in here, going to give us a negative p. Minus, well, there's no constant in that's just a plus q equals 0. That's minus 3 minus p plus q equals 0. So these are not equals 0, equals 10. Equals 10. Don't give it away, Mr. Shaw. Don't give it away. Equals 10. So since it's equal 10, we can actually decide to take this show here, so I make it into 13. I could have taken this 63 and make it into 63. Alright, so let's do that. Let's put this over here, make it 63 over the right side instead. And let's take this 3 over here and add it to this and make it 13. So we're gonna get 13 over here. And so these are the two equations we're solving now simultaneously. Equation 1, equation 2. Now because they have q as the same in both of them, we can actually subtract the two equations, right? So subtract them, we're going to equation 1 minus equation 2. And when we subtract them, you're going to do minus 3p minus a negative p, which is plus p. Minus 3p plus p is minus 2p. So I get minus 2p. Then q minus q that gone. And then 63 minus 30 is 50. 50. If you divide by this negative 2, you get p equal negative 25. That's what they said up here, which is good. We're going to take this negative 25 and substitute it here for the p. So we're going to say and substitute in here, we're going to get minus, and this p is negative 25 plus q is equal to 13. So this becomes a plus 25 and carried over, right? So the q becomes 13 minus 25. And so the q becomes negative 12. Those two things are shown. So that is it done. So this question is on a pure maths paper, but can be on an hard maths paper. Alright, same question could appear on ADMAS paper, ADMAS level or this one. Then they want us to now solve it, right? Solve the equation. So we now know the P and the Q. So let's write down the equation. Let's write the function down here now with the P and the Q. So f of x, now that we know it, is 2x squared, or 2x cubed, minus x squared. P is 25, so minus 25, P 25x, Q is negative 12. And remember that x plus 3 is a factor. So we can reduce this by dividing it by that factor. Alright, so we're going to divide by that factor. So let me copy this down somewhere. Just right down here. Alright. So we're putting it equals 0 now and solving it. We're solving this part now. We're going to factorize it. So we're going to divide by the factor x plus 3. So we're gonna get x plus 3 into 20 into 2x cubed minus x squared minus 25x minus 12. Let's make sure that's what it is. Yes. Alright, we're going to divide this now. I'm in class. I'm in class. If you open the top drawer of my desk, you see the envelope in there. Top left drawer. Yeah, cool. Alright, sorry about that, guys. So I'm going to divide this by this first. Divide those two. So I'm going to get 2x squared. I take this and multiply these. You get 2x cubed. And then this times this is 6x squared. And then subtract. So this minus going to make this minus. So it's like minus 6x squared and minus x squared becomes minus 7x squared. Then these not subtracting anything, so they come back down. So you get minus 25x and minus 12. And this divided by this x now gives me negative 7x. And negative 7x times these is negative 7x squared. And this time this is minus 21x. And then you're subtracting again. When we subtract, on this one comes a plus. So it's like plus 21x minus 25x. 21 minus 25 is negative 24, negative 4. So I get negative 4x minus 12. It is this divided by this x out here now. We're going to get negative 4. And negative 4 times these gives us negative 4x, negative 12. And now when you subtract, there's no remainder because this was a factor. And then now this up here can be factorized right where it is. Let me shift this over a little bit. This can be factorized right where it is. You can actually do this on exam paper same way. So you can factorize this right where it is there. Factors of this is 2x and x. Then factors of the 4. I want the difference to be 7. So I can put the 4 times 2 is 8 and 1. And put up the sign of the bracket are different. The greater product, the minus sign, greater product is this one, make that negative, this one positive. That's what this factorizes into. So it means that f of x is the product of this and these. And if you know those factors, you therefore know the roots. So you can write f of x equation f of x equals 0 is now this times this equals 0. You know, x plus 3 times 2x plus 1 times x minus 4 equals 0. If you know those factors, you can get the roots, right? The solution values. And so if this equals 0, you're going to get x equal negative 3. If this equals 0, you're going to get x equal minus 1 over 2. If this equals 0, you'll get x equals 4. And those are your solution values. That is it. Are you alright with that?
Yes,
Are you
sir.
good?
Yes, sir.
Alright, beautiful. Moving right along. So I don't want to do this one. That's for admins. I'll come back to that. This one is pure, not pure maths, I mean. So that's pure maths. That's pure maths. I'll come back to that. This one is admins part A. Admins and pure maths. Easy, easy. Right? So we have logs on both sides. The base is already the same. We have a number on this side, so we can use a format. Bring this expression down to log of a number to a base equals a power. And this is going to lead to that this number is equal to this base raised to this power. And then we will solve this. That's your approach. So we need to consolidate the side, the left side, into one log expression. When you add logs, it becomes the log of the product. So the left side of this equation becomes the log to base 2 of the product of these two things. Multiplying this and this. So it becomes 10 minus x times x equals 4. So we have this now. So this represents a number. This is your base b. This is your power p. So this number, which really becomes 10x minus x squared, if you expand it out, comes equal to this base of 2 raised to this power of 4. And 2 to the 4 is 16. So we can transpose everything over this side. So we get equal 0 over here, x squared when this goes over, minus 10x when this goes over, and this over there is 16. And then we can factorize this side. 0 equals factors of 16 that add to 10 is 2 and 8. So this factorizes nicely into x, 2 and 8. Signs are the same, they are both negative, negative, negative. So this one will give us x equals 2. This one will give us x equals 8. I want to test if those values will work in the original equation, which they would have. I put 2 right here or 2 right there, both expressions will be good, will be positive. And if I put 8 right here and 8 right here, again, both expressions will be good. So these are 2 valid answers. So that's the answer. When you do log testing, it's always good to test the answers in the original equation that you're solving. Make sure it won't have you finding the log of a negative number. That's what it's mainly about. You cannot find the log of a negative number. You also cannot find the log of 0. So any value, any solution that will make your original equation be calculated log of 0 cannot be used. Alright, that is it. Alright, we're not ready for this as yet. Not ready for that as yet. This is pure maths. This is pure maths as well. This, we don't do these topics yet. Don't do these yet. I think there's a circle on it. On this paper. Number 3. For add maths. This is pure maths. We're not ready for this as yet. Or that one. I think there's another question on this I told you today, and I think so. That was it for add maths. That was it for add maths. I gave you this to do as well, man. I gave you this. I'm sure I gave add maths this one to do.
Yes, sir.
Right. It says line L is this equation, right? That's a line. And a circle is this one. So clearly, this one is like is the center of the circle is 0, 0. If we write as x minus 0 squared plus y minus 0 squared equals, and this 9 is 3 squared. So this is clearly now a circle of radius 3 passing around the origin, right? Origin, the center, pass 3 here, so 3 here, so minus 3 here, so minus 3 there, so the radius is 3. All right. Sometimes when you're clear about what you're working with, the question is easier to do. And you have this line now, which is a negative gradient line. This line is a negative gradient line. So this line would be, if you write in standard form, it will be y equals minus 2x minus 3. So the line with it passes through minus 3. So it passes through here. Let's look at it. Pass through here now. Minus 3 has a gradient of negative 2. So the gradient of negative 2 is sloping down this way. Negative 2. So it would pass through on the x-axis where y equals 0 equals minus 2x minus 3. So it will be 2x equals minus 3. It will be x equals minus 3 over 2. So it pass through right here. So like this, so this line go like so. That's what that line is. That's a line L, and that's your circle C. You don't have to do this, but I'm sure it's always good if you have that added clarity on what you're working with, right? That is the sketch of this situation. So you have this line as it said, determine the points of intersection. So basically solving them simultaneously. No one already, that one. So you're solving them simultaneously. This and this. That's what it is all about. Solving them simultaneously. So let's do it. You're solving them simultaneously. Even though the diagram is solving them simultaneously. So this equation, I'm going to make y the subject again. So L, I'm going to write L as y equals right, so y equals minus 2x minus 3, and the circle is x squared plus y squared equals 9. So I'll take this, that y is, and substitute it in here. That's what we're going to do. It's a substitution method. So the line is saying y is equal to this at the point of intersection. So I'm going to substitute for the y here in the curve, in the circle. Simple as that. So we're going to get, or we could square this y, right now. But it don't matter. We're going to get x squared plus y squared. So we're squaring this y. So if we square that now, we're going to get, I'll put it in bracket first, minus 2x minus 3 squared. Minus 3 squared equals 9. Let's expand this now. So you're going to get x squared plus first term squared is going to become 4x squared. 4x squared. Then twice the product of the 2. So you multiply this and multiply this. You're going to get positive 6x, and then double that to positive 12x. And then the second term squared is going to become a 9 equals 0. Equals this 9 over here, sorry. And these lines cancel each other. And this combine to give me 5x squared plus 12x equals 0. So I can factorize the x and get x into 5x plus 12 equals 0. So I'm getting x equals 0, which is at this point. Right? And I'm getting x equal minus 12 over 5, which is at this point up here. And we need to y values to go with them, right? Let's find the points of intersection. So I'm going to substitute them in the line equation. So this one, substitute in the line equation, which is y equals minus 2x minus 3. Right? You plug in the 0 first, x equals 0, y becomes negative 3, 0 here. So that is this point, as we said. And the other one is where x equal minus 12 over 5, y becomes minus 2 times minus 12 over 5, and minus That's us putting this value right here for the x. That's what we get. And so the y becomes positive 24 over 5 minus 3. 3 same as 15 over 5. So y equals, what is it? Negative 9 over 5. Negative 9 over 5, that looks like. Alright. That's it. No, not negative. Positive 9 over 5, not negative, Mr. Shaw. Positive. Clearly not negative because it's above the x-axis. 9 over 5. That's up here. Those are 2 points. One point is 0, negative 3. And the other point is negative 12 over 5. 9 over 5. 9 over 5. That is it. That is it, guys. The answers right here. But all right.
Yes,
Good.
sir.
Yes, sir.
I think I finished the hard maths questions on this paper. So I'm gonna go back now and finish off with the pure maths questions now. So bam 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 bam. First hard maths, if you want to stick around and watch these, good for you, especially if you want to do pure maths next year. If not, you can go. Alright, but
All right, bye, sir.
you wouldn't stick around and try to learn something. But it's easy, man.
No thanks, sir.
Man say bye, sir. Let me see who talk. Who is it? Let me see who. Let me see who it is. You got off for this. Let's see, hold on a second. Join. Come on. Cut off. All right, let's do this one. So this one tells us to prove by mathematical induction. Hold on. Right. We have to prove by mathematical induction that this expression is divisible by this. I could have said this is a multiple of that, right? So that divisibility proof, we do the same way. So we're going to say let, do the same way every time. Pn, call this statement Pn, be such that this expression, which is 6 to the n minus 1, if it is divisible by 5, is equal to 5 times some integer value. Yeah, we state that this is an integer value. So we are saying x is an integer. X is a member of integers. X is an integer. And n is a natural number, right? So for all natural number n. So n is a natural number. And there's a 4 steps process. Step 1 is to prove that it is true for n equals 1. So you're going to say for n equals 1. You plug the 1 in there. You're going to get 6 to the 1 minus 1. That is actually 5. 5 is 5 times 1. So it's 5 times an integer for you. So you can say P1 is true. So it is true for n equals 1. Alright? Second step is to assume it is true or make it true for n equals some value k. Alright, I already defined n as natural number, so k must also be a natural number. So that is the case. We're going to plug k in this. So you're going to get 6 to the k minus 1 is equal to 5 times. I'm not going to put back x. I'm going to put some quotient. And that quotient is also an integer. And what I've done here is assume that pk is true for n equals k. Pk is true. When doing this proof, you always have to substitute something from this line down into the next step. Practice and all that, and we are going to be able to find that in the next step. So it makes sense to recognize what this would be as a subject. This would be that 6 to the k would be equal to 5q plus 1, and that's what we're going to be substituting in the next step. Because induction phase, you have to use something from step 2 in step 3, which is where n is now k plus 1. So step 3 is where you're showing that this is true for n equals k plus 1. All right, so for n equals k plus 1, you're now putting k plus 1 in the expression. So it's going to become 6 to the k plus 1 minus 1, but you're not going to write no 5 times nothing yet. Make it work out itself. That's what it is. What you're trying to do now, you're looking for example, this expression in here, which it is, because this is the same as 6 to the k times 6. That's what this is. Right? 6 to the k times 6 to the 1. You can write it as that, 6 to the k times 6 minus 1. And then what we can do now is take this and substitute for the 6 to the k right here. And that's how we make the substitution. This is going to replace this 6 to the k. And so it becomes equal to 5q plus 1 times this 6 out here minus 1. And we need to show that this expression now is 5 times something. Alright, that's what it is. So we're going to expand this out and get this time this becomes 5 times 6q. I just want to keep the multiple of 5. Then 6 times 1 is 6. 6 minus this 1 is 5 minus 5. So this factorizes into 5. These two terms factorizes into 5 into 6q minus 1. And 6q minus 1. And therefore we're going to be a multiple of 5. And this q is an integer. So this expression is an integer. So therefore it means that pk plus 1, that's what we are at. Pk plus 1, because we use n equals k plus 1, is true if pk is true. And because you have shown this, right, you can draw the conclusion on step 4 that therefore by mathematical induction, the original statement up here that we call Pn, this original statement Pn is true for all n which are natural numbers, and that's your proof. Quick and fast, nice and easy. Alright guys, are you alright with that? Alright, let me assume yes since nobody answering. Let me assume yes. Let's continue. Alright, let's do this reason and logic. So they give us this truth table. P and Q are two propositions. We have to complete the truth table. That's a conditional statement. Remember, a conditional statement is true only here when the antecedent is true but the consequent is false. That's the only time this is false. And I said true, whatever I mean false. It's true everywhere else. That is it. This is or. Or is true, any one of them true. So true or true is true. True or false is true. False or true is true. But false or false is false. Now this is and. And is true only when both of them true. So true and true is true. True or false. True and false is false. False and true is false. False and false is false. So and is true only when both of them true. Then we are doing this conditional statement now. So what are we doing? This one is this, and this one is this. So we are looking for true implies false equals false. Everything else is true. We're looking for this between these two. So we're really not focusing on these two. So we're doing these two to get that. Alright, which is right here. True and false, true and false. So those are the two false ones. True implies false. So false, false, true, true. And that's the completed table. But good? What is that? Everybody good with that? Mr. Watts, you good with that?
Yes, sir.
All right. It says now, state given reasons for your answer, whether the following statements are logically equivalent. So I want us to compare these two. This one, put it in purple. We're comparing this one with this one. And they're not the same because these two values not the same. See that? Spoil it. Not the same. Not same. Right? And it says whether foreign statements are logically equivalent. Right? It says give a reason. So they are not logically equivalent. Because the truth values are not identical. They don't have the same truth values. This values are true and that values are false. Everything is good enough, but those two spoil it. Those are the ones that cause a problem. You can asterisk them, make it stand out, and then asterisk down here. Truth values are not identical. Those that we have asterisk, put asterisk on are not identical. But all right, good.
Yes, sir.
Right, we're going down to see what we're gonna do next, and then we're gonna do this one. This is sum and product of roots of a cubic equation, similar to sum and product of roots of a quadratic equation. That's your cubic equation right here. You see it has roots alpha, beta, lambda, right? And I want us to find the sum of the roots, that's a pairwise product, and that's a product of the roots. So sum of the roots, which is alpha plus beta, alpha plus beta plus lambda is minus b over a, which is, this is a b, right? So it's minus negative 5, and this is a over 2, which becomes 5 over 2. And the pairwise product is alpha beta plus alpha lambda plus beta lambda is c over a, and this is a c, is 4, and this is a which is 2, which is 2. 4, 2 is 2, and then the product of the roots now, which is alpha beta lambda is minus d over a, and this is the d, minus 6, and this is a that works out to be negative 3. So those are the three values right there. Alright, 3 marks, 3 marks, 3 free marks. Nobody have any business getting those wrong. It says answer otherwise determine the equation with integer coefficients. They want integer coefficients. It has these 3 roots. And that equation takes this form. Equation is x cubed minus sum of these 3 roots times x squared plus the pairwise product of these 3 roots times x minus the product of the 3 roots here, p3 equals 0. So s is the sum of the 3 roots. This is the product of these 3 roots pairwise, and that's the product of the 3 roots. And I'm giving us some help. tell us that this equals that equals that. Okay, I wrote this out what this is right now, you know. We have these values at the top, right? We can just write this out right here in front of us. Equals. What was it? What was the pairwise product again? The pairwise product up here was 2. I can copy these and them closer to us. Let me see. Copy. Put them down here. Let's put them over here. So these are right in front of us, right here. Alright, I'm going to work this out from now. And I'll do this on the exam paper. Just work out what this is from now and then use it, right? This thing right here. So the pairwise product is 2. So right here says 2 squared. So we have 2 squared minus 2 times, and the product of the 3 roots is negative 3. So this is negative 3. And the sum of the roots now up here is 5 over 2 times 5 over 2. And put what that value is from now. So I have to work it out again. Well, this is 4. This 2 cancels this 2. This negative cancels the negative and make it a positive. And then we have 3 times 5 is 15, right? 15, so it becomes 4 plus 15. 4 plus 15, which is 19. 19 that, right? Then this now, that's square. We can work this out again. So we have a sum and this, right? So this becomes equal to the sum up here was 5 over 2. See there? 5 over 2. That's this. Minus 2 times the pairwise product. The pairwise product is this 2 right here. So 2 times 2. What is your code? So now this is 5 over 2 minus 4. This 4 is same as 8 over 2. 5 minus 8 is negative 3 over 2. Alright, so we have those two values. Alright, so we need to find the sum, the pairwise product, and the product of these 3 roots now. Alright, let's go one at a time. So the sum first, it's written in purple. So the S is sum of these 3 roots. It is 1 over alpha squared plus 1 over beta squared plus 1 over lambda squared. And this is going to become, what's going to happen now is you want to make this into one fraction. So you multiply this one by beta squared, lambda squared, top and bottom, multiply this one by alpha squared, lambda squared, multiply this one by alpha squared, beta squared. So this is going to become up here. You're going to get beta squared, lambda squared, plus this one we're going to get alpha squared, lambda squared, and this one you're going to get alpha squared, beta squared all over, and we're going to get alpha, beta, lambda all squared. That's what we're going to get. Alright, let's make this a little smaller. But understand that though? Make it into one fraction, guys. Easy. But we good with that?
Yes, sir.
Right. And then this thing up here now is what they gave us right here a while ago, which is 19. This is just 19 over. This is the alpha beta squared. Alpha beta lambda all squared, which is the product of 3 roots here, so negative 3. That's negative 3 squared. So that is 19 over 9, maybe smaller. That's 19 over 9. Yes, 19 over 9. Then we need the pairwise product of these 3 roots now. So we're going to do P2. So you multiply these 2 first, you're going to get 1 over alpha squared, beta squared. You multiply these 2, you're going to get plus 1 over alpha squared, lambda squared, plus multiply these two now, and get 1 over beta squared lambda squared. To make this into one fraction, multiply this one by lambda squared over lambda squared, multiply this one by beta squared over beta squared, multiply this one by alpha squared over alpha squared. So you're going to get lambda squared up here, so plus, we're going to get beta squared up here, so we're going to get alpha squared up here, so over the denominator is going to become alpha beta lambda all squared again. Oh no, this works out to 9, same from here, so right? 9. But this numerator is this, which already worked out to be negative 3 over 2. Already worked out to be negative 3 over 2, so we have to work out again. So it becomes, if I were to make this a little bit smaller and a little bit lower as well, it becomes this thing up here that we did. This, no, sorry, this right here that worked out already. This expression is on the top here, right? It's minus 3 over 2. It becomes minus 3 over 2 over, this one is becomes 9. It becomes 9. Alright, and then this reduces to, I can put 3 into this one time and 3 into this 3 times. And then this 2 can come on this, so it will become minus 1 over 6. Minus 1 over 6. Minus 1 over 6. I can put another bit, minus 3 over 2 times 1 over 9. Yeah, minus 1 over 6. Right, that's what I get. And then we need P3 now. P3. P3 is the product of these 3 roots. So P3 is the product of these 3 roots. So P3 becomes 1 over alpha squared, beta squared, lambda squared. And multiply these 3 things. That's what I get. So it becomes 1 over alpha beta lambda all squared. So this again is 9. So it becomes 1 over 9. Alright, so put in these 3 things now up in here. This one go in here, this one go in there, and that one go in there. The form of our equation. Alright, so I can grab off for the red for the equation now. So the equation is x cubed minus this s, which is 19 over 9x squared plus plus p2. P2 is this. So if I add a negative, it stays negative. So it becomes minus 1 over 6x. And then we'll do a minus p3. This is p3. And so that is 1 over 9 equals 0. And then say them want integer coefficients, right? See? Integer coefficients. The integer coefficients will multiply by a multiply of, let's come and multiply of 9 and 6. That looks like what, 18? 9 and 6, 18. So multiply 2 by 18 to get integer coefficients. Multiply by 18. Multiply by 18. This becomes 18x cubed minus multiply this by 18, but multiply this by 2, we get 38 x squared. Multiply this by 18, will become 3. Multiply this by 18, can become 2 equals 0. And this is the answer right here. That is it. Nice question. Nice good question right there. This one. Nice good question. Alright, guys. Alright, guys. Are you good? there another one for you to do?
Yes, sir.
I had another one for you to do. That's it. Pure maths, 4D, 4D already. 2A and 2C. I think we're done. I think we're done for pure maths. All these topics we don't do them yet. Yeah, trades. We don't do trades yet. We don't do geometric equations, vectors. Vectors is now going to be doing soon. Only vectors yet. I think vectors is our next topic actually. Low cost is very easy. This got a coordinate geometry. Yeah, we're done. I'll give you 4A. 4D, sorry, it is that one. Alright guys, that's it. I'm gonna send the video into the group so that persons can have a look back, redo the questions, if you got anything wrong or if you did not do it. I'm gonna send the questions, but that's it guys. Well, good night. We'll talk. I'll message in the group if we're doing anything Sunday. I don't want to teach anything new. I just want us to revise that because anything new I'm doing, I want to do it face to face. So for the rest of the day, we're not going to do anything new. We're not going to do anything new online because some persons away and all of that. So that is it. So do another revision session if anything Sunday, Tuesday as well, and so on. Alright guys, so I'm gonna send this in the group as I said, and we will talk. Bye everybody. Nobody answers. Alright, I'm gone. Bye.